In this video, I want to talk about Java's hash map. It's a powerful new data structure that does a lot of cool things, and I hope you'll start to see where it's useful to use. But just like an array and array list, it takes some practice to get used to using it. So let's do a little exploration of hash map. A hash map is an example of a more general data structure called a map. And a map basically relates two things. There's something called a key and the value associated with the key. So if you have something like a first name David, maybe a last name Johnson associated with it, maybe if you have a name like David, maybe you associate a user ID with it, or a university ID with it, and you can basically, by using the name to look up things, you can get the value associated with it. So it's a very general structure. We are used to thinking about arrays that have an index, and that we access a value in arrays through the index number. So there's only, in that sense, the key-like thing is just a number. In a map, it can be much more general, like a string. And array also has ordered values, and we don't really have that sense of ordering, at least with this particular kind of map. We can often write a map. We use curly braces to distinguish it from an array, and this is the key, and this is the value associated with that key. This is another key, and this is the value associated with that key. So again, it's a way of associating two things, and the association is not just number to value, but it is some sort of more general thing, like a string to a value. So a hash map is also an example of a collection that uses generics to say what kind of information it's holding. And so there's a generic type for the key and a generic one for the value. And it looks a little intimidating, to be honest, because even a single generic looks a little bit odd as we first learn about them, and having two of them certainly ups the complexity. But if you start using it, it's not so bad. So this is saying that my key types are going to be strings, like a name or something like that, and the value associated with each name is some sort of integer wrapper class. And so I'm going to call this a name ID map. So I'm going to associate a name to some sort of ID number, and it's a map. So I'm going to make a new hash map. Again, I'm going to use the empty diamond here because it's already declared here, and I'm going to start off with an empty one. And you should Google how to initialize it with some values if you want to start off with some default values in your map. And I have to import this as usual. Import hash map, and it's good to go. All right, so what can we do? We can put in a new key value pair. Again, we have to think about this in more like pairs, right? But there is a precedence. It's the key is sort of how you access thing, and the value is associated with it. So you can't look at like 100 and find. You can't look at 100 and find the key, right? You have to look at the key and find the value. So I'm gonna have my name ID. It's lowercase. Am I doing ID map? A little different now. And I'm gonna say put in there David, and I have an ID of 100, right? Who knows what that means? And I'm going to, let's print out this map now, check what's in it. Oof, I keep hitting the wrong modifier key for my complete. And so I'm gonna have map name ID map. And if I run this, notice the curly brace. Oh, I forgot Java actually uses the equals to associate the key and the value. I put a colon in my slides between them, and that's what Python does. So slight variations across languages, but they basically are trying to say the same thing here. I'll probably update the slides if you go look. All right, so let's put something else in there, and we'll print it out again afterwards and see how it changes, how it sort of updates over time. So I'm going to put in Sally, and I'll put in 1,000 for Sally. So now we have these two. Notice Sally wasn't stuck on the end. There's something going on. We're not sure. There's a lot of different ways to implement maps, and in fact, that's a very exciting area in like an algorithms class to discuss this. But we're going to ignore that for now. All right, so let's see. I can get a value associated with a key. So let's make a little more space here. Okay. Oh, I'm going to use my name ID map and get the value associated with a key. Right? So sometimes you want to look up the value associated with something. So with David is 100. I can, or I'm not going to do it. I'm going to remove. I can remove pairs. I can remove a key value pair based on a key. So if I remove David, it actually removes the David and the 100, right? Because they're both associated with each other. Now get, if I try to do something that's not in there, so if I ask for get on Joe, what happens? It gets a null value back. This is actually very convenient because with an array, you get an index out of bounds exception if you put in a bad index, right? One that doesn't exist. It doesn't give you some null value back, and that's probably because an array can, array can hold primitive values. An array list, I guess, could have done something like that, but you can always figure out a proper index to ask of an array list, right? There's no reason you should get an index out of bounds except for just sort of doing some bad code in the first place. It's a little harder to check with the map because, again, what keys are there? We don't really know, right? We can only sort of probe at this and ask, hey, are you here? Give me your value. So getting null back is useful. There's also, I think, another useful form that you can say get or default. In other words, if Joe does not exist, give me a default value. So there's two parameters in here. This is the default value that's returned if the map does not contain Joe. So I get that 0 back. And anyway, you'll see some various uses for that kind of stuff, but it's nice to have that option. And we can also just check directly for containment if we want to. Contains, just like the array list. So again, you sort of get used to the different, contains key. I'm sorry, you have to ask whether a key is contained in the hash map. And in this case, it is false that Joe is a key in the hash map, right? There's only Sally and David as keys. Now, we can do a for each loop to loop over keys with a little effort. So I can say, for example, what kind of things are the keys? They're strings. That's what we define the hash map to be. So for string key is the name ID map, and I need to say, give me the set of keys. All right, so this thing evaluates to the keys, and then we loop over that to get each one at a time. Notice this is a set. You can't actually have repeated keys in a map, right? Because that's how you associate a value with it, and you can't have two Davids in there. What would that mean? There actually are things called multi-maps that do have repeated ones, but the basic map, basically, there's a key. It'd be like having two things at one index in an array, right? It doesn't make any sense, basically. And so I could print out the key that we get. So if I run this, I get Sally and David out. And again, you should be careful thinking about the order, whether that's set or not. And then you can also loop over the values if you want. And values, of course, are not a set because you can have like multiple hundreds, right? You can have David 100, Joe 100, Sally 100, right? So they're not a set, so it's just the values here. And these are integers. Integer val u. I'll spell it out, right? Value. And if I run that, I got the key Sally, the key David, and then the value 1000 and the value 100, which is what's stored in this map. So those are kind of common behaviors. There's also other kind of search things. You can ask well, it contains, and so on. You can actually pull out the pairs if you want it. There's something called the entry set. It has both the key and the value, and so you can get sort of both at the same time. You can look that up if you're interested. But these maps are really great for associating different kinds of things, and they're really generalizations of arrays in some sense. Like the fact that array maps an index number to a value is sort of a limited thing, and here we are mapping some sort of general object, like the key value, a string, a double, a file, all sorts of stuff to some stored value. And so anytime you see sort of more general associations between pairs of things, a map is a really great data structure to try to hold that kind of information. Thanks.